Welcome to another short subject from EducateVirtually.com. The origin of control chart rules. It all starts with a standard normal distribution. One of the things that we know about the standard normal distribution is that the mean is equal to 0 and it has a standard deviation equal to 1. These rules were developed by Walter Shewhart in the 1930s. So that would put them into the realm of modern day statistics. So here's our standard normal distribution, and a control chart is characterized by an upper control limit and a lower control limit at plus or minus 3 standard deviations about the average or about the mean. We've also added on to here 1 standard deviation, 2 standard deviations, and 3, and minus 1, 2, and 3. So we've broken our distribution into 6 standard deviations, 3 above and 3 below the average. We would expect to see between plus and minus 1 standard deviation about 68% of all the values. It's 68.26 if you have to be exact. Plus or minus 2 standard deviations would give us 95% of the values, or 95.45 if you want to be to the rat's whisker, and 99% would be plus or minus 3 standard deviations. Actually, that's 99.73, but we're just rounding these off. So now if I subtract these out, I can see that we should have about 34% of the values in either plus 1 or minus 1 standard deviation about the mean. I should see about 13.6% of the values between 1 and 2 standard deviations, and about 2.1% of the values between 2 and 3, either plus or minus. So this is really the basis for the rules of the control chart. If we start to see higher frequencies of data points showing up in these different zones on our control chart, then we know that we have issues. Now we know that rule 1 in a control chart would be anything above the upper control limit or below the lower control limit. That would break rule number 1. Let's take a look at a control chart now. In this control chart, we now have some zones listed on it. We have a zone A, B, C, B, and A. So here we have, here's our upper and lower control limits at plus or minus 3 standard deviations. We have our center line, the average value, and then we've added plus or minus 1 standard deviation and plus or minus 2 standard deviation lines. So now you can see here we have zone A, B, and C. So 34% of the values can be in here or in here. We can have 13.6% in zone B, and we only want to see about 2.1% of the values in zone A. This allows us to interpret special causes or conditions of unnatural variation in a control chart, even though we haven't gone above the upper control limit or below the lower control limit. But if we're starting to see too many data points showing up in these zones based on these percentages, then we know that we have issues or special causes. It would be an unnatural situation of variation. It would not be a normal natural random pattern of variation, which we would call common cause, but it would be special causes. There'd be some reason. So this is where those control charts come from. They're based on the standard normal distribution. Now if you're using individual values to plot your control chart, we need to test the distribution to make sure that it's normally distributed. So these rules do hold true. If you're using subgroup data where you're plotting the average value of a subgroup, that distribution is always normally distributed, and we don't have to worry about testing for normality. So that's the origin of the control chart rules, brought to you by EducateVirtually.com. online training, online consulting support through Webinar on Demand, visit us sometime. Sign up for the newsletter. Thanks for your attention.